Welcome to the third talk of the day, the front-end family tree. I promise this will make more sense in about 30 minutes. My name is Emma Twersky. I am on the core Angular team at Google. And so obviously, who better to start talking about React than someone on the Angular team? I promise it'll make sense. Again, just stay with me for a little bit. I'm here to talk about my favorite framework, which is all of them. The secret that I think a lot of people don't know is, and I definitely didn't know 3 years ago before joining the team, is that frameworks have a lot in common, right? No social media troll on X or Twitter or whatever they're calling themselves these days is ever going to be like, yeah, they're the same, they're all great. That doesn't get views, right? But under the hood, the mechanisms that run all of the frameworks that you use in your daily life are surprisingly similar. And in fact, the two most widely adopted, Angular and React, are extremely similar. At their core, both frameworks evolved from this idea of model-driven UIs. So in both frameworks, we use plain values, no special wrappers. And when I go to change a value, there's some trigger in each framework that knows when to run synchronization, right? It knows when to take those values and give them to the page in some way so that your users can fill out a form or read your blog or whatever you're doing. And both frameworks use a concept called dirty checking, or a diffing operation, to determine what changed and what part of the UI needs updating. So when we're running that synchronization, the framework needs to know how to do that, and that's essentially called dirty checking. In Angular, we diff the data directly, and in React, you diff the virtual DOM, which is a term I'm sure many people familiar with React have heard. And in both of those frameworks, that synchronization operation works against some subtree of components, right? So both frameworks were smart enough to say, like, hey, when we diff data, we don't want to diff all the data all the time. We have this subtree of components, and we're going to figure out how we can more intelligently diff that data. And in fact, those ideas didn't just evolve separately in like two tunnels of sound that never talk to each other, right? Like, the reason these frameworks are so similar is that there's not a lot of people writing frameworks in this world. There's millions of people using our frameworks, but framework authors are pretty special, and we recognize that there's not a ton of us, and so we're friends, and we talk. And I think an open source conference is a great place to talk about that collaboration and that community. And not only are the authors friends who talk and share ideas, but our frameworks are really part of a family tree, or like a network that have interconnected relationships, and are part of this much larger family tree of frameworks that have evolved over time that use this idea called dirty checking. So we've evolved independently, and we've evolved together based on the changing needs of the web ecosystem, and we've all chosen to optimize based on different things as they come up over time. And today I want to start by challenging your idea of where these frameworks got these ideas and how they've contributed to the web and each other over time. And it may seem like most problems are solved by like a single eureka aha moment, but for any major innovation, especially on the web, that's just simply not the case. So take components, for example. We all use them if we're developers. Like, raise your hand if you've written a component. Okay, so pretty much 100% of people, we're just going to say, otherwise you were like tired or crossing your hands. And the reason for that is that all frameworks have some idea of this component. But it's not that one framework just like thought of a component and everybody sort of got on board, right? It was really not a linear idea or a single start, but many steps forward in this like web of innovation. So the first sort of hint of a component came about in 2010 when AngularJS, the predecessor of current-day Angular, was the first modern framework to put the declarative model-driven UIs on the map. right? They came up with this idea of like declarative model-driven UIs and really brought that to the web for the first time in like a major adoption way. But in AngularJS, template and UI logic was separate. So there wasn't really this idea of how we could combine them together and create something sort of modular like we know it today. But the pieces were there at the start. And it took 3 years for React to follow and say, hey, AngularJS, that's pretty cool, and that MVC approach is working for a lot of people, but we really want to focus on the view layer of that. And they really introduced this idea of components with React.component, which was a way to abstract the template and its UI logic in something called a class with a render function. And as many of you know, this isn't what React looks like today because we continue to evolve, right? Like, not a single aha, but we kept going with this. So 3 years later, modern Angular launched, which was a rewrite of AngularJS. And it was heavily inspired by React and by itself as AngularJS and its predecessor. And so it took this idea of this class component, and it introduced the concept of a component declared with a component decorator. And this stays with Angular into modern day, right? Like, we still have these class-based components, we have these decorators, and together we sort of wrap it in this idea of a component, using that same idea of like a model-driven UI with modularity that's reusable and composable, but evolving on this idea not just syntactically of like what these look like and how developers write them, but also under the hood of the mechanisms of how we're going to like process all of this on the browser. And that evolution hasn't just stopped there, right? We didn't just land in 2016 and say, hey, we've solved it. So in 2018, React continued to evolve and said, hey, I like what we're doing with class-based components, but we actually have this idea of functional components that we recommend migrating to. And this looks like a lot more what maybe modern React or Next developers are used to today. So again, if you look at that evolution, like the pieces are there. There's actually some like Angular syntactical sugar in like how this function sort of is composed, but they've moved to this like functional component model. Same component idea, just a little different. And today, there's sort of like a tree of how this evolution has continued, right? So most frameworks on the web have some idea of a component, which if you think back a decade, like didn't exist. And now every framework is drawing on this idea in some way, but taking the things they like from the past frameworks and changing them in some way, cross-pollinating ideas. New frameworks have launched and are inspired by these component models of our frameworks and others, but we've collectively learned from one another over time, and we haven't landed on one solution, right? I don't think that there's one way to write on the web. There's a lot of ways based on a lot of optimizations and trade-offs, but we've all iterated on this research done before us. And really what that ends up looking like is instead of a linear line of innovation, innovation is a system. It's a series of interconnected frequencies, not a single light bulb turning on that only strikes the most brilliant of like framework developers that we all then follow blindly into the future. Even the light bulb was invented simultaneously by 21 different people in different parts of the world. Edison got the final patent over the line, but that innovation didn't just happen in like one single lab at one time. And even since then, these aren't the light bulbs we use today, right? Like, I like a warm-toned light bulb, not an incandescent. And so this framework family tree is really the same thing. It's an interconnected set of like innovation happening simultaneously, interconnected by this like family web, where we're all bringing revolution to the web together. And that family tree isn't so linear, right? So remember how I said that innovation was more like a system or a network? Angular and many other frameworks have stood the test of time. None of these frameworks came out of thin air. And it's not just components that did this, right? So the first iteration of Angular, AngularJS, drew inspiration from a ton of predecessors, Rails and jQuery, which you wouldn't really even categorize as modern JS frameworks the way that you know them today. From there, we have Ember. That was also sort of in this like first wave of innovation and drew a ton of inspiration from Rails, as well as handlebars, which Yehuda Katz, the author of Ember, actually also previously worked on. But it also took AngularJS's SPA, or single-page application capabilities. And then we had Backbone, which learned a ton from AngularJS, but also from Rails's MVC approach. And Knockout joined sort of, again, that first wave of innovation and learned from handlebars and jQuery, but also introduced important concepts really early on, like computed properties, that are things that some frameworks are like just getting to today. And then that sort of second wave happened, right? Think of like that second wave of components, where React really like started this second wave by saying, hey, AngularJS, MVC is cool, we're gonna drop the M and the C, just focus on the V. But it was also inspired by Backbone, and Redux was heavily adopted by state management and drew a ton of inspiration from Elm's state management. The second version of Angular, or modern Angular today, obviously drew a ton of inspiration from AngularJS, but we also looked at all the innovation that had happened between the time of AngularJS and Angular 2 launching, and drew from React, from all of these other frameworks and what they had done in the meantime. Since then, Vue has taken a ton of inspiration from pretty much everywhere. So AngularJS for template authoring and binding, React for the view-only approach, Knockout for those computed properties, Elm and Redux for the Vuex state management, and Svelte has simplified much of what came before it, drawing from many modern framework concepts, but leaning more heavily into the compiler, which could be a whole nother web of innovation, right? And so we're all part of this same history, where we've all taken ideas from one another. We all share them, both in open source and on the web, and also in our like personal interactions. And the reason that we're all part of the same history and we're all sharing solutions is that we're all innovating and solving the same problem, right? These are all frameworks written for developers, by developers, and what we really want is to create something that developers love to use, that provides them a great developer experience, and that's performant on the web. And there's a lot of good reason for why we share these insights with one another, right? Angular and React specifically, just speaking from the Angular core team, have over 10 years of developer feedback, right? We have millions and millions of monthly downloads on NPM, but also even more millions of developers that over their history have touched our frameworks and also used other frameworks and have really valuable insight, unique bugs. There's a million reasons to be open source, right? I would never think of the ways that people use our framework until they open an issue and I say, I could not have ever thought to do that. And so if you think about 10 years of collective knowledge, we've started to get wise with age. And for Angular, we've seen a ton of developer insight and feedback, and we've seen tons of people find success. But we also are deeply aware of where cracks do start to form, right? You can never future-proof what you are building so far that it doesn't have to change or evolve in those 10 years. And we can rely on other frameworks to bring the innovation of the things that we've created and evolve past it. But we'd also like to be a part of that innovation and evolve with those other frameworks and take inspiration from them, right? This should be circular. It shouldn't be linear in one direction and leave the past behind. And one of the things that we've really started to see that started to worry us on the Angular team is that developers struggle to maintain performant applications. As your application gets bigger and bigger and bigger and bigger and bigger, and you add those components that we all know and love, the model complexity increases, and dirty checking just takes longer, right? Like, we all are part of this dirty checking family tree, and we love it for all of these great reasons. It has this magic. But it wasn't written to withstand the test of time of 10 years of developers continuing to just add and add and add. And there's a lot of terms on the web that just simply didn't exist when Angular was written, right? Like, developer experience is a term I'm sure you hear a lot now. Didn't exist 10 years ago. Even performance, Lighthouse, core web vitals, these are all things that have like evolved over time since our start that we want to take into account when we think about how we're innovating. And Angular's not the only one with this problem, right? So Angular and React both give developers options for how to manage that increased workload as your components scale and you reach these sort of like performance cruxes that are sort of built into like the natural path of dirty checking. So in fact, Angular and React separately came up with the same two techniques for how we were going to focus on managing this increased workload, and those were tree pruning and memoization. Tree pruning is an optimization technique for dirty checking where some components can be skipped if we know that they haven't changed, right? So if we think back to that subtree of components and we think back to dirty checking our components to see if something's changed, it's really smart to say, hey, instead of checking the entire tree, I'm going to more granularly look at what parts of my subtree or my subtree of components I know I have to recheck versus which ones I can skip. And the more I can skip, the better, right? The more granular I can be about a change, the better. And so React supported tree pruning for class-based components with should component update, which allowed a component to decide when it needed to be re-rendered and updated. And Angular's onPush provided exactly the same mechanism, avoiding dirty checking of a component when it wasn't required, right? So we both individually came up with essentially the same thing. You'll notice that this was in the component version of React, and that a lot of those sort of granular ways to look at the lifecycle hooks of a React application went away in some of the more functional methods. But essentially, this is the same idea. Oops. OK, well, I moved this slide, but I didn't mean to. And then that other version is memoization. And so skipping components that don't need to update is a good start. But what about if a component does need to update, but only parts of it, right? So again, we're great, we write components, and I'm sure we never write components that are too big or handle too much logic within them, right? Our components are small. We would never write a bloated component. But for the 99% of us who have applications that do, memoization is the technique that both frameworks came to the conclusion was the best way to do this. And so memoization is a technique for optimizing expensive computations such as array filtering, caching results, avoiding recomputation, unless the specific dependencies of that computation change. So think about if you have like a massive array that you're filtering and you know that nothing in that array has changed but other parts of the component have, wouldn't it be nice if you memoize that result, you have that result to cache on the browser, and you don't have to redo that computation every time to update that component? So in React, memoization was supported using the useMemo hook, which uses dirty checking to memoize that expensive computation. And in Angular, we have the concept of pure pipes, which hid that technical term of memoization a little bit more, but does exactly the same thing, just with a different API and similar semantics. The problem with pure pipes that we found is that they're tricky to write, and they only work in templates. So we've considered in Angular, what if we look at React, like the most similar version of another framework doing memoization, and introduce something like useMemo to Angular, right? This would be one way to solve this problem. We know that people are doing expensive computations and components. Wouldn't it be nice if we offered something like this? The problem is we're not sure that it really solves the problem we want to solve, right? We could do this. We're part of the same family. We have dirty checking. We have all of the semantics and mechanics to do this. But developers still have to opt in to everything I've talked about, right? You have to opt in to useMemo. You have to opt into writing pure pipes. You have to opt into should component update. These are all like developer opt-in things, which in this new world of developer experience really doesn't solve the problem, right? You still have to maintain a cache key as your application changes and know that you need to do that out of the box as you're learning this framework. And so we feel like we've reached a fork in the road, right? We could keep going down this road of optimizing dirty checking, of saying like, let's add useMemo, let's really focus on how we can like prune this component subtree more. Let's figure out like all of the developer APIs we can give you and put in your hands to fix these things. But what we'd really love to do is to integrate performance consideration by default and find ways for developers to build applications without having to manually optimize them. So we still want to figure out ways to optimize them, but wouldn't it be nice in open source if we could look at other innovative ways that people might be handling this, that do more of what we're excited about doing. And we've seen that there are Angular applications already doing this, right? We looked into open source, we looked into this innovation, and there are applications that keep performance under control even as they scale. But rather than lean into dirty checking, these applications are using a different technique called change notification. And what change notification is really doing is it's using RxJS observables to deliver fine-grained, targeted information about when the model changes and which specific components are affected by change. So this is really great, but we also can learn a lot about all of the applications already doing that, and we know that they're not doing this without a cost, right? It requires, again, keeping track of state using observables instead of plain values, which, if you'll think back, was one of those core similarities we had with some of our dirty checking family of framework. But for that price of giving up plain values, they avoid the need to keep tuning performance as their application grows. So they're performant by default, which is really that key word we're looking for as we look into this space of innovation. We also noticed that we have a few things going for us to change, right? So we can be deeply introspective as framework authors and say we love our framework and we know its pros and cons. And we know that we have some specific things that we're positioned to that make Angular uniquely ready to make a change in this space. First off, there's all of these people in the Angular community already reaching for these patterns and tools, right? RxJS already works, onPush already exists. There's all of these people already using this change notification model that are familiar with it, that know how to work with it. And so it's not like completely just dropping something new in developers' laps that they've never seen before. We also know that Angular components don't rerun, which I didn't go over the differences of dirty checking frameworks, but does make us unique, right? We're making it easier to integrate a different approach to updating the UI because we're not relying on Angular components to rerun every time you make a change. Similar to that virtual DOM model. And we already separate the static and dynamic parts of our template in our compiler, right? So we already know when we're compiling things onto the browser as a framework that we're separating our static and dynamic parts of our application. So we already know that things are dynamic and could possibly change. And so for that reason, we felt that we were uniquely positioned to be ready for this. So we took a look at the dirty checking frameworks and what they were doing. We saw how they were, again, not really meeting that performant by default thing that we were excited about in terms of innovation. And so we took a look at the family around, or the web of innovation happening around our family, maybe in a sister family tree. And what we found were signals. And so we're trying something different, and we would love your feedback. But Angular version 16 introduced a brand new rewrite or visit to our reactivity model using signals. Signals, if you're not familiar, is a system that granularly tracks how and where state is used throughout your application. So it allows the framework to optimize those rendering updates out of the box by default. A signal is a wrapper around a value that can notify interested consumers when that value changes. And signals can contain a value, really any value, from simple primitives to complex data structures. The change really becomes thinking about what granularity of change you want to track in your application. So I can access a signal's value through a getter function in my template, and I can allow Angular to track where that signal is used. So in this example, I have a single counter, and I can increment it, and I'm only going to update that counter value if something inside of it changes. There are much more complex versions. For example, if I add an isEven computed, the isEven value will only recompute if one of its dependencies, so here the counter signal, changes. And if anything happens outside of that, I'm not going to need to ever update this, and I know because my model knows that tree of dependency that nothing's going to be changed. So computation automatically track their dependency and eliminate the need for maintenance. You eliminate the need for that memoization key, and essentially you get this very performant by default fine-grained reactivity model. And Angular was well positioned for this, and we have a ton of work to do to really fully integrate this system into the framework. But other frameworks within dirty checking also are really well positioned for signals. Preact shows that React is really well positioned to also explore signals if they were interested in doing so. And we see a lot of opportunity for a more fine-grained reactive framework for Angular, but also for this dirty checking family. And we're not alone. We are joining an entirely new family tree of push-based reactivity frameworks that are already doing this. So we're still syncing to the DOM, we're still dirty checking, we're not leaving that family behind in any way, but we're joining this new family and no longer need useMemo with computed to prune component subtrees, right? So we're reaching for fine-grained reactivity to address how we scale the dirty checking model in a performant by default way. And I guess we're sort of just like marrying into a new family tree so that we have the best of both worlds. But we also have the ability to join a bunch of frameworks that are already doing this and have been doing this for a long time, right? I mentioned computed values in Ember. That was in that like first wave of innovation way back in like the 2010s, like a decade ago, right? And a lot of frameworks have seen this coming and adopted this as one way to solve performance on the web since their innovation, right? So Solid, Vue, Ember, Knockout, they all have versions of signals to do a push-based reactivity model. Signals aren't the only way to do push-based reactivity. But this is, again, a different way versus that dirty checking. And they're solving the same problems, just taking a different approach and making different trade-offs. And so we really are all a family of frameworks, and I think we can all learn from one another. This is one story of how in open source today, frameworks are really looking at one another to make changes and innovate on the web and push the modern web forward. But we're all doing this in both families. Angular has learned a ton from React, and we think that React and these other dirty checking frameworks can learn a lot from Angular right now and how we're innovating. We would love to get your feedback on Angular v16. Angular v17 comes out early next month. If you have any questions, I will be up in the front afterwards. But please keep an eye on the space, explore these new APIs as we make these changes into a push-based reactivity model, and learn from the innovation of all of the frameworks and open source tools, not just in your family of whatever you work on, but in the open source worlds as a whole. And thank you so much.